Hello everyone and welcome. My name is Muhammad Shams. I'm a computer engineer and in this course we're going to be discussing differential equations. So the first question that pops into mind, what is a differential equation? So simply put, a differential equation is an equation that involves one or more derivatives of an unknown function. It relates to the behavior of a function to its rate of change, like providing a way to describe how a quantity changes with respect to another. So, if this sounds weird to you in any way, in a nutshell, it's just an equation having a um, a derivative of a variable with respect to another variable, if that makes sense. So if you still don't understand what I'm talking about, you need to revisit the concept of differentiation and integration here. So yeah, that's that. And there are two types of differential equations. The first type are ordinary differential equations. These involve a single independent variable and its derivatives. And the second types are partial differential equations. Um, these involve multiple independent variables and their partial derivatives. In this course, we're going to be focusing primarily on ordinary differential equations. So, what would what is the expected outcome when you finish this course? Well, simply put, you're gonna be solving. You will be solving these problems right here. So, first, we're gonna be talking about first-order differential equations, then Fourier series, higher order differential equations, and we're gonna be learning what is the meaning of the word order here, and then Laplace transform. Then we're going to be solving simultaneous differential equations. So the concepts here are a bit abstract. Like this course is primarily focused on solving abstract differential equations instead of just knowing how to apply differential equations. And we're going to be using this reference right here, Fundamentals of Differential Equations and Boundary Value Problems, with these two authors here. I believe there is a third one, which I don't remember his name actually, but that will be the whole path in this course. And as I mentioned, it will be primarily focused on how to solve differential equations using different techniques, and most of the problems we're going to be solving are a bit abstract. You won't be able to really um, find a linking and why not to real world applications. But if you try like to find a link and link this to a real world application, actually differential equations have wide ranging applications in various fields of science, engineering, and mathematics. Like here are some key areas, some of the key areas where differential equations are applied. First, it is applied in physics. Well, in physics, it is used in describing the motion of objects under the influence of forces. And if you could recall, that's Newton's second law. Second law. Okay? Also, it can be used in modeling the behavior of physical systems like oscillations, waves, heat flow, and fluid dynamics. Also, it is used in formulating quantum mechanics equations such as the Schrödinger equation, which is quite like complex to solve. Then, in the field of engineering, we could use differential equations to analyze and design electric circuits, modeling and optimizing mechanical systems such as vibrations in bridges and buildings. Third, it will be useful in understanding and controlling chemical reactions in chemical engineering as well. Then, in the field of biology, it can be used in modeling population growth and dynamics of species, and it is used also in describing the spread of diseases in epidemiology. Also is used in economics and finance. We could use it to model economic systems, including supply and demand, evaluating investment strategies and financial options. And we could say it is also used in environmental science. It can be used in predicting and managing pollution levels in air, water, and soil, and also analyzing climate change and its effects on ecosystems. And if you may have felt like it's a bit like these fields or the applications of differential equations in these fields are involving something like it relates to the behavior of a function to its rate of change. So most of the applications in those areas are related to some change of a variable compared to another variable. Also, it is used in machine learning and data science, which is quite trendy nowadays. It is used in certain types of modeling and prediction tasks. And machine learning and data science are now a relatively large trend, and you can use differential equations to predict using machine learning and data science. Also, in computer science, it can be used in simulating and modeling various phenomena using numerical solutions to differential equations. And that's about it to our introduction to differential equations and their applications. And as we've mentioned before, this course heavily focuses on how to solve differential equations. So that's it for this introduction video, and if you want to access the complete course, you should visit aprimo.com.